Last pre-lesson. Here we go, 4-5. I'm not even 100% sure we made it this far because it's the first time we've ever taught this curriculum, but just to make sure, here we go. Starts out with, actually this is what your work, some of your work is going to look like. You're going to have to solve equations that are kind of wacky looking. So I want to make sure we start by comparing what we've been doing, expressions to equations. So remember, let's go ahead and start here, okay? This is an equation. For example, 2 plus 3 equals 5. That's a true equation. What that means is, if this is a teeter-totter, I've got perfect balance. This side is perfectly balanced with this side. So if I multiply this side by 6, that would be 12 plus 18 equals 30. And it's different looking, but it's still perfectly balanced. I know that doesn't look balanced, but it is. It's perfectly level. So what I'm saying is, here you have an equation. It's weird looking, but this is perfectly balanced with this. So if I don't like fractions, I can just multiply by the smallest number that these will go into, which in this case would be a 6. So I'd multiply, 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 and I'd get 2, because 3 goes into 6 twice. 2 times 1 is 2. And then 2 goes into 6 3 times. 3 times 1 is 3. And you got to hit everything with it, so that'd be 36x. Now I'm not going to, I might as well finish this. 5 equals 36x. Divided by 36, divided by 36. And I get 5 over 36 equals x. That'd be my answer. See, I'm finding an answer. I solved for x. See, now this is an expression. And the reason I have that on the board is to remind you that if you're thinking, oh, I just learned a trick. I don't like fractions, so I'm going to multiply by 6. Now that would be similar to having a problem like that in first grade. And instead of saying 5, which you know is the right answer, you think, oh, I'm just going to multiply that by 6. I mean, you would never do that, and you would never get the right answer, because you cannot multiply an expression by something just because you think it's convenient. So that's why we've been spending a lot of time in the previous lessons saying, hey, what are we doing? Adding fractions. There's no way about it. No way of avoiding it. You got to find common denominators. You got to go through the work. You just have to. So 3 times what is 6? 2. So I got to multiply the top by 3. So it'll be 2. 2 times 3 is 6. So I got to multiply the top by 3. So it'll be 3 6. So I get 5 6. So be careful. Understand the difference between expressions and equations. Expressions, there's things you can't do. Equations, there's things you can do. So this problem right here is very similar to some of your homework. You're like, ew, that's yucky. So what does this section kind of want you to understand? That this is your denominator that you don't like. You prefer that it's not there. But it is perfectly balanced. It's an equals. So we have this is perfectly balanced with this. So I'm like, ooh, I don't like that. I'm going to multiply this side by x plus 4 over 1. We'll go ahead and write it like that. And this is x plus 4. It is over 1, but here's the thing. I've been hitting you guys hard with, when I multiply fractions, I cross-reduce, then I swoosh. So these cancel over here, and that's my whole goal. So there's technically a 1 and a 1, and then swoosh would just give me 1 equals, then I distribute 2x plus 8. Subtract 8, subtract 8. So I get negative 7 equals 2x. Divide by 2, divide by 2. I get negative 7 halves equals x. And there you go. This is on the easy end of the spectrum. This one right here, a little more difficult. It's got more stuff, but don't panic. We want to get rid of that, and we want to get rid of that. So it's like, okay, I think I know what to do. I'm going to multiply by that so we get the cross-reduce thing going. So I'm going to hit that with this, that with this, that with this. So going to show my work on this one, but after you do 10,000 of these, here we go, you stop showing your work because you do a lot of math in your head, but this is 5x over x minus 2 times x minus 2 over 1. So there it is. Now the reason I didn't put that over 1 is because I don't see any cross-reducings coming, so I just leave it like that. So here, these cancel, which is good, so I'm left with 10. Over here, I have to distribute, doink, doink, 7x minus 14 plus 10 equals, and then x minus 2's cancel, swoosh, I get 5x. And I've got this equation to solve, so I'm going to subtract 7x from both sides, and I'm going to add these together at the same time. So I get negative 2x equals negative 4, divide by negative 2, divide by negative 2, so x is 2. And remember, we have a problem with this, and that is we got x minus 2 in the denominator. Now we probably should have done this right away, but the only thing x can't equal is 2. And then we go down here, we're like, wait a minute, so the only answer I got was the one that x can't be. That means this problem has no solution. This is, the fancy name is, this is an extraneous root, but don't worry about the fancy pants stuff. All right, I got one more thing to show you in the pre-lesson. Final problem. Might as well save the most interesting, I'll use the word interesting, but really potentially confusing stuff for last. So, hang in there. I'm going to do my best to explain this to you, but it is the strangest stuff I know of. So, we are up to example 2 from page 225, textbook. I'm going to read it, and then we're going to talk about this a little bit. So it says, Arthur and Cheyenne can paint a wall in 6 hours when working together. There's the key. So, a couple things to know. They work together. That means they start at the same time. That means they finish at the same time. So, we're going to talk about that a little bit. It says Cheyenne works twice as fast as Arthur. Interesting. How long would it take Cheyenne to paint the wall if she were working alone? Now, the first thing we know, put this book down a second. The first thing we know is the first story is they are working together. And then they start asking a question about what if Cheyenne, did this on her own. But in order to figure anything out, we got to start with the first piece of information, and that is it took 6 hours for them to finish this wall together with the knowledge that Cheyenne works twice as hard as Arthur. Now, with all of that, or twice as fast, maybe not twice as hard, but with that being said, the ability to solve this problem hangs on that formula right there. The rate at which somebody works times the time they work is going to equal the amount of work they get done. Now, there's some interesting things that happen with this formula. So if we divided this side by time, so I'll just show you, they would cancel, and then I divide this side by time, I would get this brand new formula. Now, what's this little triangular dot thing? It means therefore, okay, in shorthand, I think. Well, my professor taught that to me, so instead of writing therefore all the time, just bing, 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 therefore, rate equals the amount of work done divided by the time. It's just one of those formulas that's true. Very interesting formula, though. So if we take each piece and we say, okay, the amount of, we're going to break it up into Art and Cheyenne. Now remember I said they're working for the same amount of time. So I'm going to replace those with X's. Now we don't know how much they do, but we do know that if Art finishes one thing, no matter what that is, removing, a lug nut from a tire, or painting a wall, like he finishes that, he does that one thing, or maybe a half a one. I'm not trying to confuse you. We know that Cheyenne's working the same amount of time, but as far as the amount of work does, she doubles his amount of work. So this is the first time you guys have ever seen something like this. It might be confusing, but you'll see the repetitiveness of this if we just keep working together and practice a few problems. But now, the finished job represented by a number. Now, this is where, I'll be honest with you, it's a little confusing to me, but in this problem, they want to finish a wall. So that one represents the wall. So if it was, paving a driveway with cement, it would be a one because it's one job and they want to finish it. They don't want 90% of it done. They want all of it done, represented by the one. Now, how long did it take to finish the job? It takes 6 hours. So now we have an equation which is going to allow us to find x, which is going to allow us to answer questions about this. So all this turns into is 1 over x plus 2 over x equals 1/6. Now this is connected to what we've been learning. So we're going to multiply this by 6x, because that's the only thing that's going to eliminate all these denominators. So 6x over 1 times 1 over x plus 6x over 1 times 2 over x equals 6x over 1 times 1/6. Just showing my work. So now we're going to cross-reduce swoosh. So these x's go bye-bye, so I get 6. These x's go bye-bye, so I get 12. Equals, these 6's go bye-bye, and if I swoosh everything, I get x. So x is 18. I'm going to pause this a second. Well, I guess, for now, 18 is the amount of time it took, so that in order to finish, let me pause this a second. So I just had to wrap my brain around how to explain this. So we got 18. Now remember, this is the whole job completed in 6 hours together. Now if I take that x and I only focus on Art, and I say, okay, it would take Art 18 hours to finish that job. But Cheyenne works twice as hard. You could use a little common sense, or twice as fast. I'm sorry, I keep saying twice as hard. You could just use a little common sense. So if she works twice as fast, then if Art took 18 hours by himself, this has to be 9. But the key is if I still put 18 in for x, because that is what x is, and I reduce that, she would finish the job. That's what the 1 stands for, remember, from over here? And then that'd be 9. So she would finish it in 9 hours. Maybe one of the strangest math problems I can introduce to you. That's your pre-lesson. So don't skip the example problems because there's a little more, slightly different change with this.